Now we're going to look at how to add or subtract polynomials. Before that, we're going to take a look at the difference between these two definitions, terms and factors. So first of all, we can look at the factors. Whenever we hear the word factor, just like the examples we did before, so if they want you to factor 6, it's going to be 2 times 3. So only multiplication is involved. So maybe factor of 24, that's going to be 2 times 2 times 2 times 3. So as we can see, when we say something is a factor, there's only multiplication involved in that expression. So we call 2 a factor of 24, or 3 a factor of 24, or maybe 4 a factor of 24 because 2 times 2 is 4, or 8 is a factor of 24 because 2 times 2 times 2. But in either case, as you can see, it's only multiplications involved. But we could also have variables, say 3x squared y, and as you can see, x squared means x times x, that's only multiplication, and between 3 and x squared, that's multiplication, between x squared and y, that's multiplication. So each of them, so 3 is called a factor, x is called a factor, x squared is a factor, and y is a factor, or 3xy is a factor, and so there are lots of factors. But for terms, this whole thing, terms are usually separated by plus or minus signs. So you cannot call 3 a term, you can call 3 a factor. But this whole thing can be called a one term, 3x squared y or 3xy squared, that's one term. And we can add, say, 2x and minus 3y, and that would be 3 separate terms. And so the plus or minus signs, they were separate terms. And also in chapter 1, we reviewed how to combine like terms. So like terms will be, that means what we call them similar terms. They must have matching variables, and their corresponding exponents should be the same too. So for example, 3xy squared and 5xy squared, they are like terms. But 3xy squared and 5x squared y, they are not like terms. Although they have the same variables, they don't have the matching exponent. That square has to be for y. So these two are like terms which can be combined, but these two are not like terms. They cannot be combined. You cannot add them together 8 of anything. So this first section, we are going to look at more examples involving more parentheses or brackets. So in the first question, we want you to add these two. We call them polynomials. So all of these are called polynomials. Add means addition, so we're going to add these two. In the first case, whenever we do addition or subtraction, we want to find the like terms. So with the parentheses here, usually we like to get rid of parentheses first. And notice that on the outside of parentheses, there's nothing. You can put a 1 there if you want to, but when you distribute a 1 to the inside, it doesn't change anything. So we are going to get exactly the same thing. 1 times 13a squared b squared is itself, 1 times negative 8ab is itself, and plus 1 times 6a squared b squared is itself, and plus 2ab. Okay. Now, we are going to combine these two like terms, 13 plus 6, it's 19, and copy in the variables. And combine these two like terms, that gives us negative 6ab. And next, these are not like terms, so don't combine them. And also, we're not doing a factoring question, so this is already the final answer. You don't have to do anything else. In the second question, we are also adding 3 polynomials here. So we're going to distribute the 1 in front of there's like an invisible 1. So pretty much we can get rid of all the parentheses just like previously. So when you distribute a 1, it's not going to change anything. The same here. So we have minus 5x squared, positive 1 times negative 5. It's just going to be negative 5x squared. Positive 1 times negative 2x, it's negative 2x, and plus 1. And the same for the third parenthesis. So we're going to get negative 6x squared minus x minus 3. Next, we're going to find all the like terms that we can combine. So we have 3 minus 5, negative 2. Negative 2 minus 6, negative 8. Now I'm circling all the x terms because they match. So it's negative 4 minus 2. The sign always goes with the number or term behind it. So negative 4 minus 2 is negative 6. Negative 6 minus 1. There's not a number, but it's a 1 there, invisible 1, because it means one copy. So whenever you see x, it's the same as 1x, because 1 times x is x, or 1 copy x. Okay. Now, so we have negative 4 minus negative 2, negative 6. Negative 6 minus 1, that's negative 7x. Finally, we're going to add those constants. They don't have any variables. So negative 2 plus 1 is negative 1. Negative 1 minus 3 is negative 4. So there are a bunch of sign numbers here involved. So be careful when you add or subtract the sign numbers. Now, in the next example, we have some of these two are subtraction. We do need to be careful. The first one, we distribute a 1. It doesn't change the inside. But when we distribute a negative 1 to the parentheses, we have negative 1 times 5. That gives us negative 5n squared. Negative 1 times positive 3, that also changes this plus to a minus. Similarly, negative 1 times 2n, it's negative 2n. And negative 1 times x, that times 8, that's a negative 8. And now we can combine like terms if there are any. So these two are like terms. That's 2n squared, 7 minus 5. And negative 2n is the only term that contains variable n. So let's keep that. And all the others are numbers, so we can combine those. Negative 3, negative 5, negative 13. So that's the final answer. In the last example, we see parentheses inside brackets. And we start from the innermost. And there is one mistake I often saw is some students, they try to get rid of parentheses and brackets all together in one step. That is possible to do, but it's difficult. And I always see students make mistakes. So let's try to slow down and don't try to get rid of parentheses and brackets in one step. And also remember, it is okay to get rid of brackets first, but again, some students get confused. So it's better to always start with the inside. Even if you have 3 pairs, so maybe parentheses, another bracket, and then curly brackets, you always want to start with the most inside one. So we're going to keep everything, copying everything until we get to the parentheses. Now, there is a minus sign in front of the parentheses, so we distribute that to everything inside. So negative 1 times 3x, negative 3x squared. Negative 1 times negative 5x, and negative times negative becomes a positive 5x. Negative 1 times positive 7, it's negative 7. When you get here, you got 2 options. You can either combine everything inside the brackets, or you can choose to distribute the negative 1 to whatever inside. And either way works. So I'm going to combine whatever inside. So there's a negative 9x squared minus 3x squared. That gives me 6x squared. Notice that negative 5x plus 5x. Negative 5 plus 5 is 0. So we get 0x. And 0 times x is going to be 0. Any number times 0 is 0. So you don't have to put that 0 there anymore. So these two cancel each other and bring down that minus 7. So now I can get rid of brackets by distributing this negative sign, negative 1. So we have 6x squared. Negative 1 times 6x squared is negative 6x squared. -1 times -7, that gives us a +7. Now combine like terms again. And again, similar to that situation here, 6 minus 6 is 0. So we get 0x squared, it's equal to 0 again. Anything times 0 is itself. So 0 plus 7, the 0 doesn't make any contribution. So they pretty much like cancel. You end up with a 7 as answer. So we start with a very complicated expression, but after we simplify it, we end up with a very simple answer, 7. But it doesn't have to be the case. You could still get a complicated polynomial. It's possible. So these questions are similar to what we did in chapter 1, but we do need to be very careful with those minus signs. And when you distribute them, be very careful. Don't make any mistakes. Try to slow down, write down more steps if you tend to make mistakes in those questions.